Okay. All right, so I'll give you a diagram similar to this. So our next test, our next subject here is an air handler. We said an air handler is the inside component of our split unit. It's the electrical part, though. In other words, like this air handler over here, you have a coil sitting on top of it. It would have a metering device and the evaporator coil for the inside part. There's not much to it. There's a transformer, there's a blower motor, and there's a relay to control that blower motor that we give the name blower motor relay. And that's basically all there is to it. I think I gave y'all out a sequence step with about, I don't know, 6 or 7 or 8 maybe steps in it. Mr. D, you owe me a test, right? Just see me at the end of class and we'll take it. Well, I thought I had a sequence here somewhere, but I gave those out a couple of classes in. Yeah, y'all see that air handler?
Yes.
Yeah, and this would be for inside air, well, not inside, air handler, as opposed to not gas heat, not AC. And so we can loosely follow that. There we go. So I got 8 steps, and we're going to drop the 8 because have I drawn a capacitor on your diagram? No, because on the inside air handlers, pretty much it's standard. They give you 2 brown wires, and those 2 brown wires hook up to the capacitor. You can go, well, does this brown go to this side of the capacitor, that side of the capacitor? It doesn't matter. It'll work. The 2 brown wires go to the capacitor. So at this point, since we know what the capacitor's for, helping get it started, keeping it running out of phase, we just kind of drop that off. Yes, it would have to be wired up, but there's just nothing to it. Okay? So we'll drop that step off. My first step is going to be all my line voltage into my transformer, okay? Yeah, primary of the transformer. Step 1.
You said it was clear. I write it down.
So what?
I come up there and write it down. You said it.
Yeah, if you want to, sure do.
It's easy for me. That's what we have to test on.
This will be our next test.
Okay. Yeah, I need to be able to.
Okay, so that was step 1. Step 2 is out of the other side, the secondary side of the transformer, we're going to pick one or the other, it doesn't matter which, and we're going to run to the R terminal. Now this R terminal, open that up for me, if you would, that top part. Yeah, it just bounced it. This terminal strip is, see that on the left there? All it is a place where you to wire your nuts, your wires up to instead of a wire nut. And it's a lot easier to test for power and whatnot because it's available. So that's our terminal strip. My next step, I'm sorry.
Top left.
No, to the left. Right? With all the little screws.
Right here.
And if you got close enough, y'all can read that. It says like R, G, W, that Y. Just take a look at it. Okay, my next step is going to be from G to the coil of the blower motor relay. Not to the coil, which is on the bottom. Remember all the way down. Didn't matter which side of the coil, just the one side. The coil, remember all this coil is an electric magnet that closes and opens those contacts. The ones that are normally open would close. The ones that are normally closed would open. And so it doesn't really matter here. 4 I'm gonna come off the other side of the coil and go back to the transformer secondary, the side we didn't use. Yep. That's right. So that's it on this one for the 24 volt. That's our 24 volt circuit. We brought power to the transformer. We have three wires there.
We're on gas springs down here.
No, we're on air handle.
Air handle.
So now we go to step 4. Pardon me, I'm going to go from step 5. L1 to the blower motor common. In this case, I wrote down line. I think on y'all's, I might have wrote L1 for line 1.
Well, on this one, yeah.
So this side, this is a 240 volt motor. Could be 208, could be 230, but in this case I wrote 240. It's going to have 2 hots coming to it. One of those hots is always hot. You see, is there any switch in what you just drew? That it will always have 120 volts into it. If you reached inside of that motor right now, it would shock you because it's got one hot leg to it. We're not going to ever break that. All right, my next one is, since we went from L1, now I'm going to go from L2 into the blower motor terminal marked common. And remember the other day I drew that? So if I look at these, I would call this one normally open, this terminal. I would call this one normally closed. And because this one contacts both of them, we consider that one common. Okay?
That's it.
Thanks.
Oh, I just put it on.
I'm sorry?
Just put a line. Yeah, right here. L2. Right down to
And so, y'all right now, this motor is hot right here, and we've got hot power to here. It's already to here, but I got nothing hooked up here, but it's stopped here, isn't it? It can't cross there. When the thermostat goes, closes this path, power will flow to the coil. The coil will open this one, close that one, and let it go to this terminal. So now we want to go from that terminal to the speed of our choice.
That's high.
And usually high. Now, airflow is important in air conditioning. And so, it's going to depend on what motor you have in the air handler. In other words, what blower motor. But when we use generalized terms, we usually say air conditioning or the blower motor here, high. Heat, low. So for the air conditioning, it's going to get high speed usually. The heat's going to get low speed.
Is that right?
In this case, he chose high. That's perfectly all right. On the test, if you went to medium or low, that's fine. Let's say, look at this unit here. Let's say, I'm sorry, go ahead. Oh, pardon me. You need to come off the top normally open. I'm sorry, because there's no power down there. Unless we run the power there. I wasn't looking, I'm sorry. He asked me and I just looked at the speed. Okay, so this blower motor over here, let's say they sold this unit. They said this will work with a 2-ton, a 3-ton, or a 4-ton. Okay? Obviously, 4 tons, we say in air conditioning, we said the rule is 400 CFM per ton. So if I got a 4 ton, I'm gonna need 1600 CFM. 2 ton, 800 CFM, right? And so if that thing really had that much power, on high it had 16, on low it had 800, if you were hooking this thing with a 2 ton system, you would actually want to select low. See what I'm saying? But I'm just saying, as a general rule, we usually use our higher speeds for cool, our lower speeds. Is there anything on there about the capacitor? If I don't draw a capacitor, you don't have to worry about it. If I did, we'd have a little capacitor, we'd have 2 wires labeled brown and brown, and they'd go where? Just like over there, lift that up for a second again. Like that's hard to wire up. You got 2 brown wires and they go with the capacitor, right? Alright.
They don't touch another source.
They come from internal of the motor. See, that's what I'm saying. The motor has it wired for us. They've taken one and gone to run. They've taken one and gone to start. They wired it for us. When we're on the outside unit, we had to wire it. Okay.
That's it.
That's it. So
you don't worry about DC?
nope, we're not using them in this one. We will here in just a second.
But that's how this how the test will be.
Yeah. I'll tell you what, why don't you just hang out for a second?
Okay.
Oh, yeah. Dear, if you would, give everybody one of those. So, y'all, this is a strip heat kit. When they sell air handlers, y'all, they almost always don't come with a strip heat kit. There are some exceptions that come with like 5 kW always or something like that. The problem is the manufacturer does not know where this equipment's going. Alabama, Florida, Minnesota, and so where it ends up means how much heat I need. Does that make sense? This one here has 1 strip of heat. Y'all see that? This is on 1 line. So let's say this is 5 kW. So in strip heat terms, electric heat, and basic electricity, and basic refrigeration, we say that 1 watt of electricity is equal to about 3.4 BTUs. So 5,000 times 3.413 is about what? 18,000 BTUs. If that's enough for your house, fine. Maybe I need 2 of them. So I got what, 35,000. Does that make sense? Maybe I need 3 of them. And so these are purchased separately, heat kits. And almost all of them, they're made for, you don't put a Linux in a carrier and a train and a Heil. But if you can see back here, that panel comes out. And this one's not made for it, but it would slide right into it, sit in there, and this would be in the airstream. Does that make sense? And we have to wire this in with it. Okay, the strip key. So I just gave y'all a diagram, right? That's what this is. This is a strip kit. A heater kit. So let's look at this for a second. As you look at this, on my left is a picture diagram. On the right bottom is a schematic. Remember the 2 different diagrams? On my picture diagram, do y'all see where it's labeled D1 and 2? Look over to the left. It says D is the elements. That means those are the heater strips. See where it says on the left A. When I go over to the legend, it says A is my limit control. So those are temperature switches We wouldn't draw them like that, but that's all right. What about B? What is B?
Sequence.
My heat sequencer. That's right. And so this would plug in. So if you would, Mary, give everybody one of these. Take one.
Same thing that's up there. Only thing different, you got the, they got the blow on here. There. And, what you see is right here, it ain't got that up there.
Everybody got one of those sheets. Okay, so our heater kits are going to have. Let me change this for a second here. Alright, so our strip heat, couple of new elements. First of all, some heaters, right? We're going to use some limits. In other words, high temperature limits. If it goes over that temperature, this bimetal will open up, right? So that's like a safety. And then to bring them on and off, we're going to use these things called sequencers. The sequencers on the bottom, that's the 24 volts. Everything above it is the normally open switch, right? Now, this one has two levels. The top level is going to close, and then a few seconds later, as it continues to warm up, the next level will close. When this cuts off, they're still closed because they're hot. When they cool off, the bottom one will open, and then the top one will close, right? In the same order they went on, they'll reverse themselves. This is not a magnet. In the bottom here is a little heater which warps the metal, okay? So, let's take a look at this diagram. Now, before we go any further, like I said, this would have been my test. But that would just been the first part, right? Pictorial. I would have said creating a schematic. Well, L1, 240 volts AC. L2. What was the first step on that sequence again?
Transform.
Do you know the symbol for a transform? Now this is step one, power transform. Step two was go into R, wasn't it? That's right. So from G, now where am I going? And that's a coil. Do I know that symbol? Yeah. Gotta label it.
You say you got a what?
label it. And then 4 was closing the path. Right? Step 5 was from L1 to my blower motor. Remember I said go to line? Six, going into the common terminal on the blower motor relay, right? That would have been my common. Because I didn't use this, right? We know this was there, but we didn't use it, did we?
You see that draw?
Don't have to draw it.
Okay.
I don't want y'all to think, where'd that come from? Then what was the final step, 7? Go to the speed you choose. And you chose high.
So you said don't matter with speed you choose.
Well, you want to, if I chose low on the schematic, then I want to go with low. If I chose medium on the Y diagram, then that's what I want to do. So I want to add these components here. It's on yours already. But, okay, I need a W terminal. I need my sequencer. What else? Oh, I got a heater down here with a limit already wired in. That's about it. Limit, a heater, and a sequencer, and a W. All right, so let's back up for a second. All right, let's stop on number 4. When he did this, he went from this coil up here to 4, right? Now I would insert this. Instead of going to high voltage line 5, let's insert 2 more for low voltage, okay? W. The thermostat energizes the W terminal when they're calling for heat. Remember we used the Y terminal for air conditioning? We used the G terminal for the blower motor. We're going to use the W for heat. So I need to come over here, go to the sequencer, 5. And then 6, I got to return to the transformer.
So you on this one you got.
Okay. Y'all got a whole new sheet, don't you?
Yeah.
Let's do that. What was step 1? Transformer power. L1 and L2 is your transformer. Do that. I'm sorry. I got one already wired up. Power to your transformer, right? This is air handler with 1 strip that he just gave out that sheet. Power to transformer. Step 2 was from the secondary side to the R. That's right. Secondary side to R. These are identical so far. 3 would be G to the coil of the blower motor, right? Four was the other side of the coil back to my transformer secondary side. Coil back to the transformer secondary side. We went to this side, so we come off of this side. If we brought it in here, we'd come off of here. If I brought my red here, it would come off of here. We don't care which, but the other. Now we're adding to 5 from W into your sequencer. W, what?
Number 3.
Where's 3?
You got a number on this paper. You see, you got a number like 1, 2, 3, 4.
No, I don't think I put air handler with 1 strip heat on there, did I? Gas heat, maybe?
You got a, looks like a resistor, or
It's-
coil, and 1, 2, 3, 4.
Yeah.
2 open contacts and coil.
Go to the bottom. Don't go to 1 through 4. Those are contacts. We're going to one of the bottoms.
That's on both of them, right?
Yeah, they're a resistor. They're a little heater. W to that. W to the bottom of the sequencer. And then the other side of the sequencer back to the transformer secondary part. Back to the transformer. So I got everybody together on step 6 steps. Okay. 7. Alright, we're going to go from L1 to the blower motor. Line 1 or whatever it's labeled. L2 to the blower motor common here. L2 blower motor common contact. Well, that is too, but we're not using that. I should say the top set of contacts. We'll use them in just a second. 9 from the normally open across from the top contact to the high speed. All right, now 10, I guess, from L1 into the limit on the heater. I got that. 11 from L2 into top of the sequencer. I guess that'd be 1 for y'all, or is it 2 on that side? 1. Yeah, 1's fine. Number 1 terminal on the sequencer. From L2 to number 1 on the sequencer. Alright. From number 2 on the sequencer, 2 on the sequencer to my heater. Other side of my heater, let's see. From number 2 into the other side of my heater. So now we have a problem. Customer walks into his home, selects heat, but doesn't select fan on. Leaves it on fan auto. When he does, it energizes W, which energizes my sequencer, which the sequencer heats up, closes, brings on my heater. My blower motor doesn't run. So when this thing heats up, it's going to get too hot, my limit's going to open up, cool it off. When it cools off, it'll close and the heater will come on. I've got to have a way to bring the blower motor on in fan auto. And so, to do that, we're going to come out of sequencer 2, another wire, and we're going to go to the common on the blower motor, the bottom set, okay? Out of 2, that's right, 2 wires coming out of it. And then finally, I'm going to come out of the normally closed to low. Normally closed to low.
What's the last step?
I want to come out of the normally closed blower motor contact here and go to low speed.
My drawing look like hell.
They will. All right, let's flip it over, and on the back, let's draw a schematic out. So step 1 is going to be draw me a transformer from L1 and L2. Draw me a transformer. We said that was step 1.
Bless you.
L1 and L2, draw me a transformer. L1 to L2. Step 2, out of the transformer secondary, draw me an R, right? Connect to an R. That's exactly what we did over there, although we had 11, 12 steps. 3, from my R terminal to G terminal, I want to go from G to my BMR coil. In other words, inside the thermostat here, if the customer wants, they'll make a connection between R and G. We're not doing a schematic of a inside of a thermostat. So all we got to do is draw the terminals. From G to BMR coil, and then 4 from the coil back to the transformer. Okay, so now we got something new. From the regular air handler, 5, I want to add my W terminal, right? My W terminal goes where? Into the bottom of my sequencer. Do remember the symbol for a time delay. Sequencer. Gotta have it labeled. Sequencer. Six, got to complete the path. Out of it, back to the transformer.
But then it's coming from, is that line going down to W also, or just, it don't connect the line?
What's that?
Over about an R, does the line come down?
Yeah, these connect. Yeah. However you want to draw it.
Yeah.
Sometimes we use this symbol, which means yield. An arrow means yield, but it, I don't want to make it more complicated than it needs to be, If the thermostat calls for heat, it's going to energize W. Okay, so we hadn't drawn that yet, because this was for the other one. Okay, so that was 6. 7 is right here. L1 to L1, right? From the line 1 side to my blower motor. Right? Got all this done. And then 7 was L1. That's the same thing as this right here. L1 into my blower motor. 8, other side, L2 to my blower motor common. Nine, from my normally open across from it to my high speed. Okay. What now? This here. Yeah, this is my BMR relay. Remember, it's normally open. No, I'm sorry. No, it's not. It's not a switch. It's an automatic switch. When the magnet energizes, it closes. And this one would open, but we're not using that. Okay. 7, 8, 9, 10 is going to be from L1 into my limit. Now I got to remember how to draw a limit. We'll label it limit. That limit came internally wired to my heater. So I have to remember the symbol for a heater. Heater 1. Now 11. How do I control this? With the sequencer, right? When this sequencer energizes, it's going to heat up and close that. And when it does, let's see, 11, 12 will power me onto the heater. So I have heat. That's 12. So we said that we still had to bring the blower motor on, right? So 13, I'm going to come out of this sequencer. Remember, when we looked at the sequencer up here on contact number 2, we had 2 wires coming out of it, right? I'm going to come out of it. And this is my BMR, right? I'm going in my common on my BMR. I'm going to come out my normally closed, right? BMR. What controls this? BMR. It is normally closed unless this is energized. Now I'm going to come out of this and go to, that's right, my load. So, let's see. I have power on the transformer 7 days a week, 24 hours a day. It's always hot. Transformer delivers power to the thermostat. The thermostat calls for heat. The heat energizes, closes, brings on the heater, also goes up here through the normally closed path on load. So I got the blower motor on load. Let's say somebody walks by the thermostat and switches the switch from fan auto the fan on. When they do that, power energizes G. G energizes my coil. This coil closes and brings on high. This coil simultaneously opens and cuts off low. So I'm covered either way. We never want two speeds energized at the same time. That's why we're going through the coil, the contact. Okay? Now let me just say, you're not going to be tested on an air handler with 1 strip or 2 strip or 3 strip. Doesn't mean I won't go over it some. You will be tested on an air handler with no strip heat, right? That's the first one we did. This one has 1 strip heat, right? I'll show you how to do 2, whatever. But you're not going to be tested on it. But I want you to see how you would add heat to it. Okay? Any questions? Our next test will be Monday on air handler, no strip heat, right? So we'll go over it again Wednesday. And then y'all will have the week off for Thanksgiving. And when you come back from Thanksgiving, that Monday we'll have the air handler, no strip heat test, right?
We out of school next week,
That's right.
so we have a test when we come back.
Yes, sir.
So we
Was
gonna
that
have all
the
that
28th, I guess?
We gonna get all that Thanksgiving turkey going and take the test. Like our man.
But I'm just telling you, our next air handler with no strip heat will be our next test. Just like the AC, you know, diagram. All right, so
Play real.
what?
Oh man, we gonna be full. Oh, we gonna have a test on first Alabama. Oh, we got first year.
The first one.
We have a test on
Wednesday, what?
when we come back.
Monday?
That man, we got turkey, we got bacon, we got all the Alabama playing.